Let's solve the following exponential equation. Now, in the past we used the one-to-one property of exponents, but we needed to have the same base. Like if it was base 2 and base 64, you could make them both base 2. But this is a base 2 and a base 3, and you have actually no hope of ever making the bases the same. So we need to have another strategy. And the strategy we're going to take is to take the log of both sides. So when I take the log on the left, this is log base 10 of 2 raised to the x minus 1. On the right hand side, log base 10 of 3 raised to the x. And the reason we like this is once you have the log, you can use the exponent property, which says that this exponent right here can be pulled down and multiplied by log of 2, and then this one over here can be pulled down and multiplied. So what I have now when I use that log property is x minus 1 times the log of 2 is equal to x times the log of 3. Remember, we're trying to solve for x, so we need to put all the x terms together on the left-hand side. I need to first distribute this log 2. Log 2 is just a decimal number. You can put log 2, enter on your calculator, and you'll find out what it is. But we want to have an exact answer, so we don't actually use the decimal. We just leave it here as log 2. But we do need to distribute it to the x and the negative 1. So I now have x log 2 minus log 2 times negative 1 is just negative log 2. On the right hand side we'll just carry down our work, x log 3. And now you can see I have two terms with an x. And they need to be put on the same side. And then this term does not have an x, so we'll move it to the right. So let's do this. We'll add log 2 to both sides, and we'll subtract x log 3 from both sides. Now it would be convenient if you could combine those x log 2 and x log 3, but you can't. Those aren't like terms. So let's write it horizontally. I have x log 2 subtract x log 3. That's on the left hand side, and on the right hand side I have just positive x, no x, just log 2. Now right here, that x log 2 and this x log 3 are not like terms. So just to reiterate that, I'll write it here. They're not like. So what we're going to do is factor an x out. And when I do that, I have x times log 2 minus log 3 is equal to log 2. If you're not quite sure what I did, hit pause and do this on paper. Distribute the x to the log 2, brings you back to x log 2. Distribute the x to the negative log 3, and it would bring you back to here. So that's just factoring, but you haven't probably done it before with logs, so it looks a little weird. Now, remember, we're trying to solve for x. Right here, we're almost done because that's the only place that x occurs in this equation. So let's go ahead and divide both sides by log 2 minus log 3. Now, I don't know what that is. It's just some decimal number. But that will give us an exact answer, and that's what we want. Log 2 minus log 3 is the denominator. So on the left-hand side, we have just x. On the right-hand side, we have log 2 divided by log 2 subtract log 3. Don't be tempted to cancel those log 2's out. You can't cancel unless everything's separated with a multiply. And this subtract sign right here means you can't cancel like that. That would be wrong.